let's get into key number 3, okay? And so this is going to start very similarly as to the last one. We're going to try to solve for theta. I suggested a strategy last time to do a quick replacement for this function. You may not need it, but I always think it's a neat way to approach it because it makes me realize like the math involved, like the technical parts of it they aren't so stringent. It looks weird because cosine theta is in it, but if I do a temporary replacement of a for cosine theta, this just turns into 13 times a, minus 2 is equal to 10, and we're just kind of solving for a. That's a pretty straightforward equation. It's one we've seen before, or at least encountered this type before. And so we're just going to go about our business solving for a. So 13a is equal to 12. Divide both sides by 13, of course, and we have a is equal to 12 over 13. Now that's of course not the answer because we wanted to solve for theta in this particular case. Um, and so we can now resubstitute a for cosine theta. So instead of a, let's bring back cosine of theta. So cosine of theta is equal to 12 over 13. So at this point, we have to kind of decide how we want to proceed forward because it doesn't seem like there's really any way because 12 over 13 isn't a unit circle value, which is okay, but we are asked to solve for theta, which means we got to get theta by itself. And so all right, from this point, we just need to get theta away from cosine. Now, cosine is a function, so if we want to get theta outside of the cosine argument, we have to get rid of cosine. Now, this isn't multiplication, so it's not like we're going to divide cosine or anything, but instead we're going to apply the inverse cosine. If we apply an inverse function to the function itself, cosine of theta, and it would, of course, reduce the right-hand side as well, so we have cosine inverse, or our cosine, of 12 over 13. Recall, please, that the effects of having a function and its inverse act on the same input is that they essentially cancel each other out. The inverse undoes the action of the function, and so these are gone, leaving you just with theta. And although we don't know what the cosine inverse of 12 over 13 actually is, I was just asking you to solve for theta, and so this is the answer that I was looking for. Now you could go to a calculator, like if you have a graphing calculator handy, put that bad boy into degree mode and type in the cosine inverse of 12 over 13, and it will return an angle for you. That's a straightforward procedure, but again, I was just asking you to solve for theta, and so we can actually stop here. The big part of this problem is to realize that once you get to this point, to get theta by itself, we do have to apply the inverse function. If you do something to one side of an equation, you got to do it to the other. So we also apply to 12 over 13. And so theta is now gone because the function and its inverse essentially cancel one another out, leaving you just with the inverse cosine of 12 over 13. And of course, you have the option, if you want to, plug that into a calculator and give me a decimal or a decimally defined angle value. So here we have, again, a solve for theta problem. And so before we think about doing any substitution, I'm sorry, this should be solved for x. Let's say there's a typo there. It should be solved for x. We don't have just x anymore. We have 3x minus 1. So I don't know if a substitution of cosine would make a lot of sense here. But to make things maybe less messy, I'm going to do a quick substitution and just call a 3x minus 1. And so what we're really trying to solve is 2 cosine of a equals 0. And so in that light, to get cosine by itself, looks like we'll first divide by 2. And so we're looking for cosine of a to be 0. So I know a is 3x minus 1. That'll come in a second. But if I want to look when a cosine is 0, I think I could go to a unit circle because 0 is a well-defined value for cosine on the unit circle. It looks like cosine being the x value is going to occur in a couple different places. We have cosine of 0, because listed first, of course, at pi over 2. And we also have cosine of 0 here at 3 pi over 2, or 90 degrees, 270 degrees. So let me write that down really quick. Different colors. So this happens in 2 different places. It happens at pi over 2, and this also happens at 3 pi over 2. Okay, so I did that off screen. Let me slide this back over. Alright, so if we want to know the x value, we have to know when the cosine of this function, 3x minus 1, makes it 0. And it happens two different times, pi over 2 and 3 pi over 2. And so if we know that, let me write it here, that a is equal to 3x minus 1, and we also know that this value has to be either 3 pi over 2 or pi over 2, what we know is that we need to make a those values. A has to be either pi over 2 or a has to be 3 pi over 2. Now here's where the substitution is going to pay off for us, because we actually know is that a is 3x minus 1. We set it to be that way. So that means 3x minus 1 has to be the same as pi over 2, or 3x minus 1 has to be the same as 3 pi over 2, which means I just have to solve a couple algebra equations now. So let's get into it. So we're just trying to get x by itself, and so let's start by adding 1 to both sides, of course. And so we have 3x is equal to pi over 2 plus 1. And so now let's go ahead and divide by 3. I'm going to represent it a little bit differently because it's going to help, I think, at the end. Instead of looking at divide by 3, I'm going to look at it as multiplying by a third. So we'll multiply by a third here as well. And so our final value should be 2 pi times a third, which would be pi over 6, plus 1/3. I could combine that into a single fraction, but I think this is sufficient for now. Let's do the same thing over here. This should be no different. And so we have plus 1 to both sides. So we have 3x is equal to 3 pi over 2 plus 1. And then I will multiply by a third, multiply by a third. And so my final value of x should be the result of a distribution problem. And so this should be pi, let's see, so 3's cancel, so it'll be pi over 2 plus a third. So a little phase shift, okay? And so this is really where like this substitution, like taking the 3x plus 1 out of it temporarily, could hopefully help us understand the little problem a little better. So instead of looking at the 3x plus 1, we're just looking at it as an a. So we're solving out as far as we can until we get to cosine of a equals 0, which means we're looking for an a value that makes cosine equal to 0, which happens 2 different places, pi over 2 and 3 pi over 2, which means a is equal to those values. But since a is equal to 3x minus 1, it means 3x minus 1 is equal to those values, and then we just have to do some solving to get to those actual x values. Okay, so let's go to another composite question. Again, this is probably a little more straightforward because these have actual values. So you might get confused by this writing if you don't recall it, but this notation means no different than g of f of x. And so we can proceed forward that knowledge. The last couple examples, I think I did the algebra first and then I substituted, but you don't have to do it that way. Like you can look at this as g of f of -2, and then start solving that way. And so you can do this in a couple steps. So one, we can just find f of -2. Now the f value, of course, is up here. So we have 3 over 4 times -2 plus 10. So f of -2 would be, let's see, so 2 goes into 4, so it'd be -3 over 2 plus 10. Okay. And then, let's see, adding those together, 10 would be 20 halves, so this would be -17 over 2. So then after we do that, we can really now just take g of -17 over 2. Okay. And the g value is, or g function, excuse me, is 2x squared minus x minus 3. Those x's turn horrible. Let's try that again. So 2x squared minus x minus 3. And so substituting in a value, we have 2 -17 over 2 squared minus -17 over 2, minus 3. And so we could do some cleanup here. Not quite sure what 17 squared is. 17 squared is 289. Alright, so this would be 2 times 289 over 4, because we got to square top and bottom, plus 17 over 2 minus 3. So let's see, those cancel. So that's 289 over 2 plus 17 over 2 minus 3. So 289, subtract off 17 is 272. Sorry about that. So 272 over 2 minus 3. So let's divide this by 2. So that'd be 136 minus 3, which is 133. Okay. So again, just another composite question. We were approaching this one a little bit differently, so a couple kind of tweaks in this problem. Don't forget this notation exists, but it means the same thing as the parentheses notation. As opposed to simplifying the algebra first, you can actually substitute the value since we have it here as -2. Solve f of -2, take that result, make that the argument for g. There's some kind of crazy fraction work here that we had to do, but it's not so bad. You could use a calculator just like I did, get it down to a single value. All right. Let's use Pythagorean theorem to find the value of x. So I feel another solving bonanza. All right, so we have Pythagorean theorem, a squared plus b squared equals c squared. We have x plus 2 squared up. B value, which would be the other side, x plus 7 squared up, is equal to 12 squared. So again, we have to just kind of plow through the algebra here. So we have 144 on this side. We can expand the binomial, but by rhythm, hopefully you'll be able to maybe do that ahead a little bit. But we can or if you want to expand it, you can. But in the end, we'll end up with x squared plus 4x plus 4. And over here will be x squared plus 14x plus 49. And so let's do a little simplification cleanup here first. Here we have 2x squares. Here we have 28x's. And here we have plus 53 equals 144. And so if we're set off to try to solve this, find the values for x, we're going to have to do some cleanup first. So we'll probably use completing the square again, which means let's go ahead and get rid of this 53. And so we're left with 2x squares plus 28x. That's a 28. Oh man. 28x. Let's see, that'd be 91, I think. Yes, 4 minus 3 is 1. 14 minus 5 is 91. Okay. Before completing the square, we really like an x term instead of a 2x term. So let's substitute, or I'm sorry, not substitute. Let's factor out that common term of 2 first. So it'll be 14x on this side. Then we can divide that 2 to get it on the right-hand side. So we have x squared plus 14x. Plus we're going to pick a new c value is equal to 91 over 2. And so that should be, what, 45 and a half? 45 and 45 make 90. Half and half make 1. So to pick this new c value, we're going to, and you can use a box method, and if you recall, drawing the box if you want to try to figure out these terms. But the squared binomial term will be x plus 7. So that means that'd be a 49 there, which means we're going to have 49 to this side as well. So 45 and a half plus 49 should be 94.5. Right? So 0.5, 14, 8, 9. Okay. And so now we go about solving this in the algebraic way we know how. So square root first. So we have x plus 7 is equal to plus or minus the square root of 94.5. Okay. One last step and we're home free. We'll subtract 7 on both sides. So x would be equal to -7 plus or minus the square root of 94.5. And if you want, you can take a calculator to this and give me the 2 decimal values. That's not really the point of this. The point of this is to actually get through the factoring steps and recall how to do completing the square. So that's the answer. That's an acceptable answer for me for this exercise. All right. Hey, more factoring. All right. And so you need to reach back kind of to the algebra 2 to kind of look at more examples like this. We didn't do too many quite like this because you notice here we have a fourth term. And so like the key to understanding this particular question is kind of understanding that we have essentially the same thing as if this was, say, um, 9x squared minus 16. We just happen to have a fourth power here. And so we have something like 9x squared plus 16. We can still set it up like this. We just have to make sure the last term makes a 16, the first one makes a 9. And so we can kind of guess that we have like 3x and 3x. If we're talking about 16, we're talking about 4 and 4. And then, of course, with a negative, we'll have a positive and a negative. Now, the reason I'm bringing up this question first is a quadratic because it is more familiar for us. But if you look at how this would expand, we have 3x times 3x would be 9x squares. 3x times a negative 4, and then 3x times a positive 4, those would cancel. And then we have a positive negative 4, so that would be negative 16. And so that's our coefficients worked out. The one thing that didn't work out is our power. But if you notice, we had no middle x values because we used a positive and a negative 4 and all the same numerics. And so if we want to make this a quarter, all we really have to do is to change these powers of x. And so what I mean, kind of backing up here, um, instead of having 3x and 3x, to make 3x squared, if we take 3x squared and 3x squared, that should make our power 4. Um, to make 16, we're still dealing with 4s, and again, a positive 4 and a negative 4. But this should do two things. Since we're using all the same values, but one's a positive 4 and one's a negative 4, that should create our negative 16. 3x and 3x should be our 3x quarters. 3x is the fourth. But since we have a positive value for positive 4 and a negative 4, once I multiply these two things together, that would be our positive 12x squares. But immediately when I multiply these two together, these would be a negative 12x squares, and all those terms would cancel. And so this would be an acceptable final form for this factorization. Here we're going to factor. It's a quadratic, so we'll probably set it up like this. Unlike previous homework problems, there was no common term to pull out. So we're going to actually have to deal with this 2x squares. But again, the first terms, 2x and x, have to multiply to x squared. The last term is a negative 1, so it's got to be 1 and 1. It's a negative, so it's got to be plus and minus. And so our job is just to figure out where the plus and minus go. Is it like this, or are they reversed? So when you multiply binomials out, you can use like FOIL or double distribution, however your teacher presented it. But we have to test it. So to get that middle term, we're going to multiply these guys together, and we're going to multiply these guys together. And so the question is that going to result, in this particular case, into a negative x? So we have to really do this by trial and error. So if I multiply these guys together, I get a 2x. If I multiply the inner terms together, I get a plus 1x. Negative 2x plus 1x would be a negative x, so we're actually good. This would be the final factored form for that equation. Okay, so this is a classic ACT prep question, one that you're definitely going to see. We're given three conditions right off the bat, that we have 3 to the xy power is equal to a ninth, 2x plus y is equal to 0, and of course x has to be positive, and we're asked to find the sum of x and y. So yeah, you could play like the substitute numbers game, but it's probably just faster, and honestly that's the way the ACT is designed, to actually just solve this out. So let's start with this first clue. We're told 3xy is equal to a ninth. And so we should be able to tell after this clue is exhausted what xy is equal to. And here's how we're going to do that. If we're going to make the left-hand side and the right-hand side look the same, that tells me that whatever that's the value for x times y has to be negative 2. Here's why xy is equal to negative 2. So x times y is equal to negative 2. Because if I want to make the left-hand side 1 over 9, that means 3 has to end up in the bottom of the fraction with 1 on top, and it's also got to be squared. So please recall exponent rules. The negative exponent means to move it to the other part of the fraction. In this case, it's going to be on the bottom. And then if I want to change that value to a 9, that means I have to make it squared. And that's the only way that the left-hand side and the right-hand side look the same. So that tells me xy is going to be equal to -2. Now if I look forward, the second clue I was given is that 2x plus y is equal to 0, which means I need to do probably some substitution so I can start solving for x and y, because what I essentially have here now is a system. If I'm solving for x and solving for y, I'm trying to make a decision to solve for x and y, I have to kind of pay attention to the fact that I'm told x is positive. And so what I really want to do here is to make sure that when I substitute, I'm solving for x. So what I'll do then is solve for y first. And so if I divide both sides by x, divide by x here, okay, I'll get y is equal to -2, where's my pen? -2 over x. Okay? So I'll take this information, substitute it into my second equation, and so I have 2x plus -2 over x equals 0. All right? So now we have to do some combining of these two fractions, and so let's take that over 1. So I'll use a trick I used in the previous key. So 2x times x will give me 2x squares. And then if I multiply the top and bottom of the other parts of the fraction, that will give me -2 over x, because when I multiply my last step, is equal to 0. So this is good news because I should be able to solve for x here. Let's first multiply both sides by x, but since the right-hand side is 0, this will just be 2x squares minus 2 is equal to 0. So now if I continue my solving path, add 2 to both sides, then divide by 2. I see that x squared is actually equal to 1. And so if I square root both sides, boom, 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 I end up with x is equal to plus or minus 1, because square root of 1 is, of course, 1. Now please recall that we had a condition that x is positive, right? So x is positive, which means that what I really need is just x is equal to 1, because -1, of course, isn't positive. So we're actually almost done here, because if I know x is -1, and I also know that x times y is -2, that means y has to be -2. So if x is 1, y is -2, if I add them together, I should get -1, which is option B. Right. Last one. If k is equal to -1, then what is this expression? Now, in this case, it actually is a substitution. Plug and chug, and find the value. So let's go ahead and do this. So we have x plus y over k squared, but k, of course, is -1. And so what we really have is x plus y over -1 squared. So when I have a fraction, a over b, taken to the c power, I can give both the a and the b separately those powers. And so this would be a times c over b times c. Now the reason that's important is because the bottom is -1, and if I square it, I just have 1. And so what I essentially have in this case is x plus y squared. Now if I square a value, it's the same thing as multiplying it by itself, so we have x plus y times x plus y, and so now we can just do our FOIL double distribution, whatever you want to call it, you got it. So let's go ahead and multiply x times x, that'll be x squared. Let's check the color. Okay, so then we'll take x times y, so plus xy, y times x, so plus xy again, and then finally, of course, we have y times y, which should be y squared. Of course, this is all review second hand. I know you guys can do this. So simplifying it then, we have x squared plus 2xy's plus y squared, which is how you can expand a binomial very quickly, because it tells you to square the first term, square the second term, add the numbers, multiply numbers together, and times 2. So like the result of this is if you have like an x plus 3 and you square it, you square the first term, like it says x squared. You square the last term, be plus 9. Then you multiply these two together and then double it. So 3 times x doubled is 6x. That's really what this result tells you. Anyway, that is going to be the answer, which happens to be C. Okay. So that's key number 3. What will follow is, of course, key number 4, which is the last one before you take that test/quiz on Friday.